Hello again and welcome to Project Planetree. This episode was originally going to be about the top, and as you can see we did make the top. That was done this winter. Paul and I built it and brung it out here, 600 pounds, and we lifted it up and put it on top. We're using a hoist, a winch, and a tractor, and it took a lot. But we did it. But we're going to be about, I can't just do this episode just about that. We'll have a subsequent episode to go over the details. This episode is going to be about a little bit about that, a little bit about some of the things that's happened over the past 4 months, and also we put some lines in the sand as far as where we're going. Susanna and I have determined exactly what we want the boat for, what we want its capabilities to be, and all that good stuff. So to start with, we want it to be able to do the Great Loop, and that's a 6,000 mile trip. If you're not familiar with it, Google it, take a look. It comes up the East Coast. You go into the Great Lakes, come down Mississippi, Tennessee, and then you end up in the Gulf of Mexico. You either hug the coast or you can cut across. But the bottom line is you gotta get to Florida to complete the loop. Now that's where some uniqueness comes involved. When you cut across, depending on where you left, you can leave in Texas and go down the southern part, that's days it takes to cross. So the boat has to be passage capable. When you talk about a passage capable trawler, you know, that's a big deal. But what makes this special is that's an electric trawler. Yeah, we are going all electric on it as well. And it's going to have all the amenities that you would want, but it's going to be electric. And that comes to mind, you know, there was this guy who, that's just our dream. We want to do this, and we want to prove out this technology. And, you know, we're going to use some legacy technology and along with some new cutting edge technology. And, you know, there was a guy who wanted to cross the Gulf of Mexico, and that's another thing you can Google. And this guy, he wants to walk across the Gulf of Mexico, and he does it by building this big plastic bubble and gets inside of it, and he starts going across, and inevitably he fails. And he did it multiple times. And when each time he fails, the Coast Guard has to rescue him until the point to where they just said, hey, listen, you do that again, we're going to press charges against you because you're not just risking your life, but you're risking ours. And that's a key thing of why I cut into that little story is that when we talk about we want it to be all electric, we're talking no diesel, no sails, and no stopping to charge. And that's risky because you're using that legacy technology and the new technology. Legacy meaning some of the older electrical propulsion ideas that's been around since World War II and was on the original Planetree, but also some of the more cutting technology that is of this year, 2024, and has little to no testing behind it. So there is going to be failure. So that being said, when we say no diesel, we are going to put a diesel generator in the boat. We'll rig it up to where we can run it like the Planetree did, where we can bypass everything and run directly generator to motor and run it that way to get home if we needed to. We can switch over to that alternate. But for the most part, the generator will be just sitting back there as ballast. We'll never run it unless we need it. It also will have no sails. Now the boat came with a sail. You can see on the bottom there, you can probably see the mast. But that's just a stability sail. It's not for propulsion. That just the wind hits it and holds the boat from rocking backwards and forth. And then no stopping to charge. If you're going to have a passage capable trawler, so again, this isn't like a car. When your car, you run out of power on the side of the road. It's an incredible inconvenience. If you in a boat and you're in shipping lanes and you lose power, or if you're offshore and you lose power, well, you're a victim of your own silliness. And we're not going to do that. So that's why we're going to have a backup method of propulsion. We're going to make sure we're not like that guy in that plastic bubble. You know, you got to look at that guy. He was give him one thing. He was definitely dedicated, if nothing else. So anyway, there's that. We're going to cover a little bit about some of the other things that we've done. We've done cut in a gunnel door. Just started. I may not even cover that in this episode. Probably another one. But we cut in a gunnel door. We got the top put in. Got the electric motor. Got the generator installed. Pull the shaft out and put the shaft back in with all that stuff, packing clan and all that stuff back in. So yeah, let's take a look. They say a friend in need is a friend indeed. Well, really, a friend who helps you with laminating is a friend indeed, especially if it's with polyester resin. Shout out for Paul for help on this, because this was a especially difficult part of the project. Neither of us had ever worked with Sphere Cell, which was it was a new product, and also it took over 40 gallons of resin to get it done, and it was just hard. But we learned a lot, and if we did it over, we probably could do it better, but it definitely met the need. So these conduits, what they do is they serve two purposes. One, they hold the conductors for the charging system, and also by layering multiple layers of glass and carbon fiber over them, it also helps strengthen and stiffen that top as well. So after all the ribs were fully glassed in, the next step was to add a couple of layers of XPS foam. This was added to provide a smooth surface for the headliner, but also to insulate for the sun. The cabin will be air conditioned, so it's important to provide as much protection from that heat as possible. So we glued all the foam together and to the top using urethane adhesive. It's actually urethane foam, and that did a nice job of putting it all together. And then we added 2 more layers of fiberglass and epoxy, not polyester resin, but epoxy and fiberglass on top of that. So there's our completed top. The edges look a little rough because I made it a little bit bigger than it needed to be, because I knew that my measurements, if they're off any, once I set it on top of the boat, I can saw it to the size I want it. It ended up being about 3 inches thick as a total thickness. It looks a little rough there, but with a little sanding, it'll slick out rather nicely. So actually, there was still some work that needed to be done before we could put the top on. The boat is broke down into 4 different sections, and each one of those sections needs to have a watertight bulkhead between them. And as you can see there, the bulkheads are not watertight. So we had to fix that first, and that had to be done before the generator could be put in. We could bring the generator through the door, but that would require a forklift, which we didn't have. Something else that's not shown here is that I had to remove a flange bearing from the drive, the prop shaft that went through there. And, that it was kind of a strange design. It had this regular mild steel flange bearing that was bolted on with these heavy bolts to plywood, then only held on with with number 10 wood screws. And it was completely frozen to the shaft. And I got it off of there using, a grinder. Just took a little bit of time and finesse. So going back, I went back with a stainless steel flange bearing that's mounted on a stainless steel plate. That plate rests on a bed of 60 durometer silicone, so then vibration does not resonate from the bearing and shaft into the boat's hull. This area, as you can see, this is where the generator is going to mount. These are 2 mounting platforms that I installed that rest directly on the ballast in the keel. And also, if you notice on that bulkhead there, it's now watertight. In order to make that happen, I also had to add a shaft seal so then water wouldn't penetrate into the next compartment there at the shaft. So this coating actually isn't paint. It's actually epoxy, titanium dioxide, and hydride. Hydride is powdered porcelain. It sheds off dirt, easy to wash and clean. It's better than paint. Notice also I'm using the same, the original packing gland, but with the slower RPM, if I use PTFE moldable packing, I can operate at full hull speed and be tightened down good enough where I don't drip. So I built this spreader bar or lift bar to help lift up the generator. It weighs about 800 pounds, and it's okay for it to lift it a little crooked, but it just makes it harder because the lift up there can only lift it so high. And if it's dragging across the rail as I get it over the edge, it's going to be a problem. All it is a piece of bar. I put a U-bolt in the middle. And if you notice, on this side, there's a chain that comes from here to the engine, and that's really, you know, that engine lift thing, you can see I can even move it with my fingers. It's really a balancing part. The load is actually being held over here on another one that's much more substantial, and so it's kind of goes diagonal to the generator, and it you know, kind of interesting is that dot there represents where I'd guess the center point of gravity is. Because if you look, the generator slightly overhangs its feet on the front side. And so I measured it out, and that's where I thought it was, and turned out when I lifted it up with a strap, that's exactly where it was. You know, it's maybe a quarter of an inch off. So anyway, I think she's good to go. I haven't really put a big lift on it yet to see how well she holds. I'll lift it up and see. So here you can see two different engines. The one on the right is the one that came out of the boat, and the one on the left is one we sourced thinking that we were going to put a diesel engine back in the boat. Both of them are 50 horsepower motors. As you can see, the original, which could get us to, get us very easily to hull speed, was only 42 horsepower at 2,800 RPM, which you achieve hull speed way before you reach 2,800 RPM. I surveyed many other Willard owners, and you actually reach hull speed somewhere around 18 to 2,000 RPM, depending on your hull configuration and that sort of thing. So looking at that, at about 1,800 RPM, you're looking at about 24 kW and that's based on a theoretical propeller loading, and we'll talk a little bit more about that as well later. So it's a pretty straightforward and simple calculation to determine your hull speed of a full displacement boat. It's essentially the square root of the length of your boat at the waterline, and then it's multiplied times a constant. So for this Willard, and you can see on the top we have the original, and the bottom is a rendition of something similar to where we're going to end up. The hull really doesn't change. So doing that simple calculation, we come up with about 7 knots would be our top speed that we can reach with this boat. We're starting to get enough information now where we can define the characteristics of our propulsion system. If 32 horsepower equals hull speed, and hull speed is 7 knots, which is about 8 miles an hour, we can use that information to start defining the propeller and shaft speed now to maximize the benefits of electric propulsion. So now we can use the horsepower rating that went from the chart and some of the history and some of what we now know to help determine what size motor that we need, which equals to about 24 kW. And that information, in conjunction with the speed and the prop that was on the old diesel engine, we can also determine what the efficiency ratio is, because we need to know how much loss and slip there was with the old system. And that will help us determine our prop size, because the pitch and the diameter needed for the torque characteristics of an electric motor is going to be much different than the torque, the pitch and the diameter that was used for a diesel. So here it is. This is the motor for Project Planetree. It replaces the diesel engine. It's a 24 kilowatt AC 3-phase permanent magnet motor. Runs on 96 volts at 300 amps. Do the math on that, you'll come up with above 24 kW. And the reason being is because it's 24 is where it's run, standard is set, but you can run more if you can abate the heat better. And that's what these two ports are here in the back. It's just water cooled. And it also has a machined flat surface on the back where you can mount it to a heat sink. Anything you can do to get rid of the heat allows you to pump more power into it. At 300 amps to these 15 millimeter diameter wires. Those are big herky wires. And you can see that the controller also is water cooled too. It's a heat plate that it mounts to. And yeah, and then see this front of it, what happens is you mount that, the plastic cover comes off and it face mounts to this plate here. And this plate will have, of course, the shaft will come out this hole, and these here are so that it can, you can align the motor and tighten up your timing belt. The timing belt is about the ratio of the little pulley to this big one. It's going to be 2.57 to 1, which is going to allow me, I think, to get around with the size screw that I have. That's layman for the prop. I keep calling it, don't forget about it, everybody calls it screw, but it should be going around 700 RPM on that shaft. And let's see this shaft here, this is where a coupling will go from it to the drive shaft of the boat. Well, it's raining outside, so that's probably going to end it for the day, but let's talk a little bit about props before we leave. Here is the prop, the new one versus the original. You really can't, the camera probably doesn't do it justice on the size difference, because to me it looks quite a bit larger. It's pitched differently. I went with a right hand versus a left hand, and also it's a much more radical pitch. You're probably wondering why I didn't use one of those prop calculators online to determine this, and I used that method. Prop calculators online are traditionally for diesel engines, and the torque characteristics between diesel and electric are so radically different that they just don't work. So I used that method, and the guy I bought this from said he could repitch it for me if it isn't quite right. So I'm feeling pretty good there. The math that I used gets me in the ballpark, but there was a whole lot more than that. I just couldn't put it all online. It would be unwatchable if I put all that on there. So if you have any questions, go ahead and put those in the comments. And don't forget to like and subscribe. That helps me out on knowing what you like and what you don't. I know this episode was a lot more dry than the first, and I'm going to try to break these down into smaller episodes in the future and do them more frequently. I know I've been kind of off on that. So anyway, like, subscribe, and we'll talk to you next time. Bye.